Welcome back. In last week's video, we walked through how to properly test your C5 Corvette's resting battery voltage, as well as what the voltage should be. Then we moved on to a much more useful test, the 10-second engine cranking battery load test, so that you can tell conclusively if your C5 Corvette's battery is good or ready for the dumpster. Now, if you missed that video, don't worry, I'll include a link in your upper right-hand corner, and you can watch it right after this one. Now let's fast forward to the point where your C5 is back running again, life is good and you're happy, but in the back of your mind, you're not 100% sure why your battery was dead in the first place. So let's see if we can figure that out.
Toys for life.
First, realistically ask yourself, how often have you been driving your C5 lately? And if the answer is not very often, that could very well be your problem. C5s contain several different modules that even when the car is not running, each one draws a teeny bit of energy, and that can drain your battery in a shorter period of time than you might think, perhaps as few as just a couple of weeks. If this is your situation, and it is a common thing for C5 owners, there's an easy fix for it. Get yourself a battery tender junior and hook it up to your C5 often. That way it'll always be ready to go. And in case you weren't aware, if you allow your battery to get to a deep state of discharge often, that's not good for it and it will absolutely shorten its life. If it happens to be below freezing, a discharged battery will freeze and that'll destroy the plates inside, wrecking your battery. By the way, this is the battery tender junior that I've had for about the last 6 years, and it's been flawless. Now, if you're the type of person that drives your C5 a lot and you're pretty certain lack of use is not the issue, then you could have a bad alternator. But luckily, with our multimeter, that's an easy check. Simply connect your meter to the battery like we've already done in this video, and go ahead and start your C5 while watching the voltage. It will drop a little bit while starting, but it should recover quickly and move to the low to mid 14-second range within just a couple of seconds. If your voltage stays in the mid to upper 13-volt range, I'd keep a close eye on it because it could be on its way out. If your voltage is 13.4 or lower, I'd probably take the battery cables off and the cable to the alternator, clean all of the connections and retighten them, and see if that fixes the problem. If you're still not in the mid to low 14-second range, I would remove the alternator, bring it into one of the better auto parts retailers in your area, and have it checked on a professional alternator tester.
Cool.
The last test I have to go over with you today is the Parasitic Draw test. As I mentioned earlier, when you shut your C5 off and it's sleeping, it still has a little bit of draw, which is normal from 1 or 2 modules that are still on. That should be in the neighborhood of around 50 milliamps or less. Sometimes there's something going on with a module or a device that's left on, and you've got a much higher reading in milliamps, and that can lead to a dead battery in just a couple days, sometimes even a few hours. A word of caution before we get started: be sure all of your doors are shut and remain shut. Make sure your underhood light is off. Make sure all accessories are off or you won't get an accurate reading. And if the current that is left to be drawn is more than 10 amps, you'll blow the fuse in your multimeter, which is a cheap fuse, but you'll have to go to the parts store to get a new one. Now, to perform this test, we're going to go ahead and remove the negative battery cable and kind of set it aside. Now we're going to go ahead and set our meter to the 10 amp scale, which on most meters requires moving the positive lead over to the 10 amp port. Okay, I've got my meter all set up here. I've got it on the 10 amp scale, negative to the battery post negative, and I'm going to connect my positive to this known good ground right here. And you can see I got a little bit of a spark when I did that, and it's drawing about 1.3 amps, which is a lot. And that's because there's a module on right now. You'll see it'll start dropping here pretty quick as different modules turn off. Now we're down to 500 milliamps. And if we keep going here, ultimately it's going to drop down quite a bit more. We're at a point where this is 70 milliamps and it's going to drop down even lower than this. So now it's dropped down and it's somewhere between around 10 milliamps, but I can't tell for sure because I'm on the 10 amp scale. and I can't just turn it to the 200 milliamps because that won't work. So I kind of have to figure out a way to test it further. I want to go to the 200 milliamp scale, but if I disconnect this lead and reconnect it, then the modules will wake back up. It'll pull 1.3 amps or whatever, and it'll blow the fuse inside of the meter if I have it on 200 milliamps. So what I'm going to do is I'm going to add another jumper wire to the negative battery post, and I'm going to run that jumper, and I did this a little bit ago to make sure I've got continuity right there. You can pick any source that you confirmed is a good ground. So now this is basically providing the ground for somewhere around 10 milliamps between the battery and the engine and the chassis. So now what I can do is I'm going to remove the lead from the 10 amp side here. I'm going to turn this to 200 milliamps, and then I'm going to plug this back into the 200 milliamp side. Okay. Now I've got 2.5 milliamps, but now I need to take off this jumper because this is taking some of the load, and move that out of the way. So basically what I'm left is I've got 18.3 milliamps of parasitic draw, which is perfect. Anything lower than 50 I think would be just fine. If you've got an aftermarket car alarm or something like that, it's not uncommon for this to be 150 milliamps, which will lead to a dead battery in pretty short order. So now you know the sequence of wires to connect and disconnect and meter settings to properly do a parasitic draw test on your C5. So what if your measurement is coming in at over 50 milliamps? Then what? Well, first I would go ahead and shut off all the lights in the shop, and I would check inside and outside of the car to make sure there aren't any bulbs on or LEDs on, things like that. Be sure to look underneath the dash as well, because there might be an old car alarm that you didn't know about that's got a little LED that you can see, or perhaps like you have an HVAC actuator that's running that you just can't hear from anywhere else. So listen for noises and look for bulbs. If it does turn out you've got an old aftermarket car alarm or remote starter, go ahead and find the inline fuses underneath your dash that go to those and remove the fuses and recheck your parasitic draw. We do this because our C5 is getting up there in years, and some of these old cheap electronic devices that were added can fail over time, and when they do, they can lead to excessive draw. If that doesn't solve your problem, it's time to dig in and start checking fuses. One popular older method involves removing fuses one at a time while we're watching our meter to see if that milliamp draw goes down. The problem with this method though is that sometimes when you remove that fuse and put it back in, it wakes up one or more of the modules and the amperage draw spikes to like that 1.3 amps again, and then you have to wait while each module falls asleep. So it's really not a great method, and it kind of takes a lot of time. Instead, I would recommend the voltage drop method, where you actually test for voltage drop across the contacts on each one of your fuses. So if it turns out there is no voltage drop between the contacts on the first fuse that you test, that means there is no current being drawn on that circuit and you can move on to the next fuse. If the next fuse does have a small millivolt drop between those contacts, that means there is a current draw on that circuit, and there's a chart I'll show you later where you look up the size of the fuse that you're testing, and then on the horizontal axis, the millivolt drop, and where those two intersect, that is the milliamp draw of the circuit you're testing, and you can use that to determine if there's excess draw on that circuit or not. Rather than reinventing the wheel, see what I did there, and going through the various steps of the voltage drop method when hunting for parasitic draw, I'm going to go ahead and leave a link instead in the description below to a video that was done by Humble Mechanic YouTube channel. He does an excellent job of describing exactly how the voltage drop test method works when you're looking for that parasitic draw. And look for that video in the description below, because that'll be an excellent resource. And it's also got that chart that we have to reference between the fuse size and the millivolt drop to get your milliamp draw. If you like this video and you learned something from it, please throw me a bone by hitting the thumbs up below and leaving a comment so that YouTube knows to share it with the C5 community. And as always, thanks for watching.